All right, ladies and gentlemen, welcome to part two, factoring by grouping, where we actually start doing it with quadratics, but we're going to give this a little nickname that we're going to call it split the middle. Okay, and the reason why we call it split the middle is because we're taking a quadratic trinomial and we're going to write it as a four-term quadratic. So we're going to kind of take that middle term and really write it as a sum or difference. So that's going to kind of give us a little extra term. Okay, this is going to be our go-to method of factoring quadratics where a is greater than 1. You can also do guess and check if you have really good number sense. That's the way that I normally go through and do it. But this way is a little bit more procedural, and more of my students tell me that, hey, can we just always use this? And the answer to that is yes. Okay, so we're going to be factoring by grouping, and the way that that's going to work is I'm going to illustrate it with an example. So we're going to look at example 4 since we're really just continuing from earlier. So example 4 says to factor the quadratic trinomial 2x squared plus 17x plus 21. This has a leading coefficient. That 2 is the leading coefficient. That's not a 1. Because that's not a 1, I can't do the kind of factoring that I'm kind of used to doing, where I just look at the value of c and say, oh, well, what are the factors? Because what are factors of 21? Well, 21 and 1, does that make 17? No. 7 and 3, does that make 17? No. So it wouldn't really work out for you anyway. But what we're going to do is this process called split the middle. So here's how that's going to work. I'm going to take my value for A, which is 2, and my value for 21, which is C. And I'm going to multiply those two together. 2 times 21 gives me 42. Okay? Now I need to think, what are all of the factors of 42? Because I'm trying to find factors of 42 that when I combine them, I get 17. Okay? So, factors that I can think of off the top of my head. Okay, we got 6 and we got 7. Do those ones work? Well, they make 42, but do they make 17? Not really. Um, if I think about some other ones or get a calculator and start doing some division, maybe I come up with 3 and 14. Okay? Can 3 and 14 combine to get 17? Absolutely. If I multiply 3 and 14 together, am I going to get 42? Absolutely. So here's what I'm going to do. I'm going to rewrite this problem without directly using this 17. All right? So here's what that's going to look like. I'm going to take my first term, my 2x squared, and that stays exactly the same. But instead of writing plus 17x, what I'm going to do is I'm going to write plus 3x plus 14x. Okay, and that came from this 3 and this 14 that were the factors of 42 that add up to 17. Okay, then I'm also going to include the plus 21. Okay, this is why it's called split the middle. We're taking that middle term and we're splitting it to make it two terms. Okay, if I was to simplify this right here, would I get the exact same thing as my original problem? Yes, I'd combine the 3x and the 14x to get 17x. But I'm going to use this to try and factor, okay? Because once I have this part done, what am I then allowed to do? Well, I can kind of divide it up into the left part and the right part, and I can try and factor by grouping. So the GCF of the left-hand side over here is going to just be x. What's left over? Well, I have a 2x and plus 3. Okay. Over on the right-hand side, what's the GCF between 14x and 21? Well, a positive 7. Okay. And then what's left over? Well, I have 2x and plus 3. And would you looky there? What do we have? Woo-hoo-hoo! A 2x plus 3 in each part, which means that 2x plus 3 has to be my greatest common factor. So I can factor out a 2x plus 3. And what's left over? X plus 7. Okay? So that's how we can go through and factor using grouping on a quadratic, which we call split the middle. Really, it's factoring by grouping, but it's easier to just call it split the middle because that gives you a whole method to use. All right, so let's go through and do two more examples. In the second one, example 5 here, we've got 6x squared minus 11x plus 4. This obviously is a problem that has a leading coefficient of 6. Okay, and looking at 6, negative 11, and 4, I see that there are not any common factors. So I'm just going to go ahead and work on doing factoring by split the middle. So I'm going to take that 6 and that 4, and I'm going to multiply them together. 6 times 4 is 24. What are factors of 24 that when I add them together, I get negative 11? Well, if I think really hard about it, I can think about negative 8 and negative 3. Negative 8 times negative 3 gives you a positive 24, but negative 8 minus 3 gives you negative 11. So that's how I can split the middle up. So I can rewrite this as 6x squared minus 8x minus 3x plus 4. Okay? So now I can go and do a little split the middle factoring by grouping stuff. So on the left hand side, 6x squared and 8x, I can take out a 2x as my GCF, and I'm going to be left with a 3x and then minus 4. Okay. Over on the left hand side though, I notice that I don't actually have a GCF. It's just negative 3x plus 4. They don't have anything in common. But there's always one value you can factor out. You can always factor out a 1. And when we're doing factoring by grouping and split the middle, if you can't factor out something, you got to factor out a 1. But remembering our little tips and tricks, that third term is negative, so I need to factor out a negative 1. Okay, and when I factor out just a negative 1, what's left? 3x minus 4. Because remember, when I factor out a negative, it changes the signs. And la-di-da, what do we have here? Matching factors, so we can factor those out. So we have 3x minus 4 is our big common factor. And then the other one is going to come from 2x and minus 1. Okay? So again, we've taken a large polynomial and we've factored it down into the product of two smaller polynomials. If you wanted to go through and check your work, you can always go and multiply these two things together. Okay, 3x times 2x is 6x squared. Then at the tail end, negative 4 times negative 1 gives you a positive 4. And in the middle, you would end up with a negative 8x and a negative 3x, which would again give you your negative 11x. So you can always check your work. Okay. Last one that we're going to go and take a look at, we've got 15x squared minus 84x minus 36. Okay, now there's some pretty big numbers that are in this one, so maybe we should really try and see if there's an overall GCF to begin with. All right, so I've got 15, 84, and 36. Well, 15 and 36, I know we could take a 3 out of. Could I do the same thing to 84? Well, if you don't know for sure, grab a calculator. Do 84 divided by 3. You end up with just regular old 28. So you could, in fact, take out a GCF of 3. So I'm going to rewrite this as 3 and then put what's left over. Okay? So we've got 5x squared minus 28x minus 12. Okay, so now I can do split the middle just for my simplified quadratic, or my more simplified quadratic. So 5 times negative 12 gives you a negative 60. Okay, so we're trying to think of factors of negative 60 that will get you a negative 28. Okay, so if you think about it, you should come up with 30 and 2. Okay, those are factors of 60 that'll get you to 28. Okay, so one of them is going to be 30. The other one is going to be 2. But because it's negative 60, one of those two factors is going to have to be negative. We're going to need it to be negative 30 and then positive 2. Okay, so that means that I can go and rewrite this. All right, so I still have a 3 on the outside. I'm not going to forget about that. And I'm going to have times 5x squared minus 30x plus 2x and then minus 12. All right, so if I go through and kind of factor by grouping here, I still have a 3 on the outside. Okay, so this will then factor into a GCF of, we'll call it 5x. Okay, and what's left is just x minus 6. Over here, we can go through and take out a 2 as the GCF between 2x and negative 12. So we're going to have an x and a minus 6, which is good news for us because that means I have a common factor. Okay, so I've got an x minus 6 and an x minus 6, so I can factor that out. But the GCF of 3 that I've already factored out just stays exactly where it is. So there's still a 3. Well, I don't know exactly what this thingamabobber is doing, but we're going to get it sorted out. Okay, so we have a 3. There we go, that's still on the outside. Okay, so I'm going to put a big bracket, and we factored out a x minus 6. And then what was the part that was left over? Well, 5x and plus 2. Okay? So, and then we could go through and close all of that fun stuff. But really what we should be doing here is just saying that the 3 itself is a factor, the x minus 6 is a factor, and the 5x plus 2 is a factor. So this could really be written as 3 times x minus 6 times 5x plus 2. Because what are we trying to do here, folks? We're just trying to go through and do some factoring. Okay, so that's a method that we can use to go and factor any kind of quadratic trinomial that has a leading coefficient greater than 1.